We are in quadrilaterals day 3, and our focus today is going to be on the sum of the angles of a quadrilateral. So for the first problem, it says, what is the sum of the measures of the 4 angles in each quadrilateral, and how do you know? The first shape we have is a rectangle. If you remember, rectangles have right angles. If you didn't know, right angles are worth 90 degrees. So I've got 90 plus 90 plus 90 plus 90. You will have a calculator, so if I add up all of my 90s, that equals 360 degrees. So the sum of the measures of the angle of a rectangle is 360 degrees. The sum of the measures of the angles of a square is going to be the same because, like a rectangle, a square is also considered a rectangle, and it too has 90 degrees in each angle. So a faster way of adding 90 plus 90 plus 90 plus 90 is to do 90 times 4, which is 360 degrees. So far we know rectangles add up to 360 degrees and squares add up to 360 degrees. It makes sense that they both have the same amount since they are shapes that both have all 4 right angles. What happens when you have a quadrilateral that's not a square or a rectangle and therefore doesn't have 4 right angles? Okay. The trapezoid we have to the right, the trapezoid that we have on the left, we have an angle of 45 degrees plus an obtuse angle of 135 plus 120 plus 60. Again, I can use my calculator, add up 45 plus 135 plus 120 plus 60, and that gives me 360 degrees again. Perhaps it's just a coincidence. Let's try the quadrilateral on the right. I have 68 degrees plus 118 plus 94 plus 80. I'm going to use my calculator, sum those 4 numbers up, and I get 360 degrees again. We've only done 4 examples, but if I were to do another quadrilateral, can you guess what the sum is going to add up to? You're right, it's 360 degrees. So when it says, can you make a conjecture, can you make an educated guess about what the sum of the angles of any quadrilateral are? If you're thinking they always add up to 360 degrees, you are correct. If for some reason you forget this, if you get to the day of the test and you're like, oh, I totally forget, what number does the quadrilateral angles add up to? Think about your square and think about your rectangle. They have 4 90-degree angles. 4 90 degrees are going to add up to 360. And if you can remember that, and you can remember that any quadrilateral will add up to 360, that's how you can help remember. Sometimes there'll be an open-ended question, and they'll say, could you create a list of angle measures that could represent 4 angles of a quadrilateral? As long as your 4 angles add up to 360, you're good to go. Now you could do an easy way and just say, oh, 90 plus 90 plus 90 plus 90 is 360 because I know that 4 right angles adds up to 360 degrees. Or you could be more creative. Let's say, for example, I have an angle that's 127 degrees and another one that's 98 degrees and another one that's 65 degrees. And my last one is 70 degrees. Would this be an example of a quadrilateral? Well, if you take the 127 plus the 98, the 65, and the 70, as long as it adds up to 360 degrees, those are the angles of a quadrilateral. If it were to add up to something like 180, that would be a triangle. If it added up to 540, that would be a pentagon. But we're just going to stick to quadrilaterals. So you need to know that quadrilaterals add up to 360 degrees. So either they're going to ask you to make one up, Or they're going to give you a bunch of numbers and you're going to have to decide whether or not it adds up to be a quadrilateral. Now remember, a quadrilateral has 4 sides and 4 angles, which means if it doesn't have 4 angles, it's not going to be a quadrilateral anyway. So if you had something that added up to 360 degrees, but it was only 2 angles or 3 angles, that's not a quadrilateral. Because quadrilaterals has 4 angles, and those 4 angles have to add up to 360 degrees. For the last part of the notes today, this is a most missed question from the SOL. So this is a really important one to know how to do. Also, it gives you an example of what the SOL questions would look like on an actual SOL. So part A asks you to name each figure using the given attributes with its most precise name. So looking at the very first shape, I can see based on those tick marks that it has all equal sides, and I can also see that it has right angles. If it has all congruent sides and right angles, that's going to be a square. In the second problem, I can see that it has just one pair of parallel sides, and I know that because those little arrows right there are showing me that those 2 sides are parallel, making that a trapezoid. Figure 3, it has congruent sides. That's what these tick marks mean. Okay. Things that have congruent sides is going to be a rhombus. Figure 4 has not just one pair of parallel sides, but 2 pairs of parallel sides. And I can also see that it has right angles. So a rectangle would be the best name for that one. I'm going to skip over number 5 just to start, and I'm going to move to number 6 first. This too has 2 pairs of parallel sides. I can see that because it has 2 arrows here and 2 arrows here, marking that those are parallel. And this side is parallel to this side. It doesn't have all congruent sides, and it doesn't have any right angles, so the best name for this one would just be a parallelogram. Going back to number 5, I don't have anything on my figure that's showing that I have parallel lines. So while it may look like there are parallel lines, I don't actually have anything on there that states that they are. However, I do have 2 tick marks on this edge and 2 tick marks on this edge, showing me that the next to each other sides or the adjacent sides are congruent, just as this side and this side are congruent. These 2 sides are not opposite each other, they are adjacent. These 2 sides, which are congruent, are not opposite each other, they're adjacent. If you have a figure with not necessarily any parallel lines, but you have adjacent sides congruent, that's your kite.